we will write or solve equations involving circle. Now, in circle, we have our standard form, which is when the center, so in circle, we will locate the center, wherein the center of the circle is at, center is at the origin. So if we speak of the origin, then the vertex is, I mean the center is located at 0, 0. So it is expected that this is our circle. Okay, this is our x, this is our y, and then our circle is located. This is supposed to be our circle with the center is at the origin, and then we have here our radius r. So that when we have the equation of our circle, you have, take note, if we write the center at the origin, which is x and then y. Okay, so I will write x and y from the origin. So we have x and then y. This is at the origin at 0, 0. Then we have x squared plus y squared is equivalent to r squared. That is our initial formula or the general formula of the circle. X squared plus y squared equals r squared. Now what if the center is at HK with radius r? So if for example this is our x and y coordinate, and then the center is at this particular point, which is HK. So we have our circle, this one, our circle. So that this HK, our general equation is x minus h squared plus y minus k squared is equivalent to r squared. So take note of that formula for the general equation of a circle. So we will have our example for finding the equation of a circle. So say for example, we have here example 1, or I will write here example. Write an equation, write an equation of the circle, okay, with center at the origin, with center at the origin. So that means at 0, 0. Okay, and radius is 3, and radius is 3. Okay, so if we have this one, to solve this problem, we have our solution. Again, the center is at the origin, so we will be using x squared plus y squared is equivalent to r squared. Okay, so since the radius is 3, then we will substitute the value of r as 3. So we have here x squared plus y squared is equivalent to 3 squared, which is then equivalent to 9. Okay, so 9. X squared plus y squared is equivalent to 9. That means our radius is 3. When we draw this one, we have here 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So our center is located at the origin. So this is our circle. Okay, sorry for this one. Okay, so that is supposed to be our circle. So I will draw first Okay, I will redraw this one. Okay, so that is our circle with center at the origin, and then you have a radius of 1, 2, 3. Okay, that is our radius 1, 2, 3. So that is the equation of a circle. X squared plus y squared equals 9. So this is, let's say this is example number 1. If we have here another example, let's say write an equation of the circle with center. Write an equation of the circle with center at, let's say, -1 and then 2. Okay, and radius is 5, and radius is 5. Okay, to solve this problem, we have here the center is -1 and 2, so we will be using the equation x minus h squared plus y minus k squared, which is equivalent to r squared. So we will be using this formula. In our first example, we use our formula x squared plus y squared equals r squared because the center is at the origin, which is 0, 0. The second example, the center is located at -1, 2. So that is not at the origin. Therefore, we will be using this equation. Okay? So this time, this -1 will be our x, and then this 2 will be our y. So I mean k. So x minus -1, okay, squared, plus y minus our k, which is 2 squared. This is 2. Our h equals -1. That is why we have here -1. And then 2, which is equivalent to our radius, is of course 5. Our radius, so 5 square. So we have x minus 1. X minus -1 is x plus 1 squared. And then plus y minus 2 squared, which is equivalent to 5 times 5, that is 25. And then take note, if we have here, if we expand the equation, let's say a plus b square, when we expand this one, we simply multiply a times a, which is equivalent to a squared, plus 2 times a times b. So that is equivalent to 2ab. And then we multiply b times b by itself, that is plus b squared. Okay, so that is how we expand our equation binomial. Another example, let's say 2 minus x squared. So we simply multiply 2 by itself. 2 times 2, that is 4. And then 2 times 2 times -x, that is -4x. And then x times x equals positive x squared. That is how we expand our binomial. So going back in our problem, so take note of that one. Going back to our problem, we square x plus 1, so that is x squared plus 2x plus 1. Okay, that is how we square this one. And then the other one, this one, plus y times y, that is y squared. And then 2 times y times 2, that is -4y. -4y minus 4y. And then 2 times 2, that is equivalent to 4. So plus 4, which is equivalent to 25. So that this one is x squared plus 2x, and then I will combine this one by this one. Okay, so plus, I will skip 1 muna, and then y squared minus 4y. So combining 1 and 4, that is plus 5. And then this 25, I mean, equals 25. So I will transfer 5 to the other side. That becomes negative 5. So we have here x squared plus 2x plus y squared minus 4y is equivalent to 25 minus 5. This becomes negative 5 because you will transfer this 5 to the other side. That becomes negative 5. So our final answer here is x squared plus 2x plus y squared minus 4y is equivalent to 25 minus 5, that is 20. So we can have this one as our final answer for finding the equation of a circle. So x squared plus 2x minus y squared, I plus 5 plus y squared minus 4y, that is equivalent to 20. Okay. Now, another example for this one. So, if you have noticed, given our center and then the radius, so we make our equation. Now, what if we describe the graph, or we will find, so example number 3, find the center and radius of the equation, let's say x squared plus y squared minus 6x plus 8y minus 75 is equivalent to 0. Now, to solve this problem, we have here our solution. We will combine all variables with x. So, x squared, we have here x squared, and then we also have here minus 6x plus a certain value here. Okay, plus we have y squared, and then 8y, so plus 8y plus a certain value here, okay, which is equivalent to this negative 75 will be transferred to the other side. That becomes 75. Since we add a value here, so we will add here plus the first value plus the second value. The main reason why we have here a missing number is to make this equation into perfect square, as well as this one. Okay, so we have a missing value from this one, and then we also have this one as our missing value. Since we add two missing value on the other side, then we will add another missing value on the other side, two missing value. Okay, now this time, if we have here x minus 6x, you have to x squared. To determine the value here, to make it a perfect square, we need to divide this value by 2. So negative 6 divided by 2, that is negative 3. And then this negative 3 will be squared. Negative 3 squared, that is equivalent to 9. So this 9 will be added to this part, so that when we write a perfect square for this equation, that is x minus whatever the value here, this one, the result of dividing negative 6 by 2, so that is negative 3. So x minus 3 square. Okay, if we check this one, if we expand, that is x squared. Take note, we have, okay, if we expand this one, take note, if we expand, let's say a minus b square. Okay, so let me check this one. I will write it here, a. If we expand a minus b squared, that is multiply a by itself, that is a squared, and then multiply 2 times a times negative b, that is negative 2ab, and then multiply b by itself, negative b times negative b, that is positive b squared. So for this case, if we multiply 2 times x, x times x, sorry for that, that is x squared. And then next is 2 times x times negative 3, that is negative 6x. And then expand, I multiply 3 by itself, 3 times 3, negative 3 times negative 3 is positive 9. Wherein this one is equivalent to x squared minus 6x plus 9. Therefore, we will add 9 to this part. Okay, so I will add it here, x squared minus 6x plus 9. That is the main reason why we have the value of 9, because of this process. Okay, so I will now erase this one. So that for this one, x squared minus 6x plus 9, the perfect square is x minus 3 square. Okay, now how about this one, this value? Okay, by following this process, so we will follow that process. So we have here y squared plus 8y plus blank. Now, take note of this one. We divide this one into 2. 8 divided by 2, that is equivalent to 4. And then, we square 4. 4 squared, that is equivalent to 16. Okay? So, we will add 16 here. So that we have here y squared plus 8y plus 16. Okay, so what will be our perfect square binomial? We have here 4. So y plus 4 square. Okay, so plus y plus 4 square. Okay, so if we check this one, y times y, that is y squared, plus 2 times y times 4, that is 8y, and then 4 times 4 equals 16, which is similar to this one. Okay, so that is now a perfect square. And then equals, since we add 9 and 16 to this side, we have here 9 and 16. So on the other side, that is 75 plus 9 plus 16. Because we add 9 and 16 on the other side, we will also add 9 and 16 to the other side. So that is equivalent to 75 plus 16 plus 9. 16 plus 9, that is 25 plus 75, that is 100. Therefore, this one is x minus 3 squared plus y plus 4 squared. That is equivalent to, we make this one a square. So, square root of 100, that is equivalent to 10 squared. Okay? So, this will be our x minus h, y minus k. So, k here is negative 4. Because this is positive, so you change the sign to negative. This one, our h here is already negative, so that is equivalent to 3. And then our radius here is equivalent to, of course, 10. So, our radius, the center and radius of the equation, so center, our final answer here is the center is located at hk. So, you have here 3 and then y equals negative 4. And then the radius is at, equal to 10. So this will be our final answer. This one, the center and the radius of our equation x squared plus y squared minus 6x plus 8y minus 75 is equivalent to 0. Okay. So that is now our final answer for the equation. Finding the center and the radius. Now, we have another example. Example 4. Okay. In the example 4, so let's say this is 4, 3, 2, and then 1. Okay, so example 4. Let's say find the equation of uh, well, the process is similar to this one. Okay, so let's say another example. We will have another example. So for number 4, okay, similar to example number 3. So again, find the center and radius of the equation x squared plus y squared x squared plus y squared plus 12x minus 2y plus 37 is equivalent to 0. Okay, so that is our example. Okay, so x squared plus y squared plus 12x minus 2y is equivalent to 37. Now, again, we will combine all x with x squared with 12x. So we have here our solution. X squared plus 12x plus a certain value here plus y squared minus 2y plus a certain value here, which is equivalent to this 37 will be transferred to the other side. That means this become negative 37 plus a certain value plus a certain value. Okay, because we add two values on the other side, then we will add also two values on the other side. So again, when we write this one as our perfect square, take note 12x divided by 2, that is 6x. Okay, and then 6 times 6 equals 36. Okay, so take note 12 divided by 2 equals 6, and then 6 squared equals 36. So that is our process. We have here x squared plus 12x plus 36. Okay, so that 12 divided by 2, that is 6. So we have here x plus 6 squared. That is now a perfect square. On the other one, in terms of y, we have here negative 2 divided by negative 2. 2 positive 2, negative 2 divided by 2, that is negative 1. And then negative 1 squared is equal to 1. Okay, so that you will have plus 1. Plus 1. Okay, so we have here y squared minus 2y plus 1. So that when we write this one in a perfect square, you have y negative 1, negative 2 divided by 2 is negative 1. 1 minus 1. Okay, we have here this one. If our first equation is 6, then the second equation is negative 1. So you will have negative 37 plus 36 plus 1. Because we add 36 and 1 on the other side, then we will add 36 and 1 on the other side. So this time, when we add this one, that is equivalent to 0. Okay? So, radius is 0. If you have noticed here, the radius for this case is equivalent to 0. So, x plus 6 raised to 2, our x minus h, so our center is as negative 6, and then y minus k, y minus 1. Okay? And then radius is equivalent to 0. So, in other words, this one is just a point because there is no radius. So, uh, it is just the point at negative 6, 1. Okay? In other words, the graph consists of a single point. Or we sometimes describe it as a point circle because the radius is 0. Okay? So that is our example for radius. Now, this time, we will proceed with our uh, discussion about parabola. So, parabola, this is another conics. So, parabola, this is another conics. Take note, when the vertex, we have what we call as the vertex of a parabola. So, if we have here parts of a parabola, we will just draw first the different parts of a parabola. So, let's say this is our parabola. Okay. Now, this one is what we call as the vertex. And then, if we have the vertex, then we also have our focus. Let's say F as our focus. This one. Distance from the vertex to focus is A. We usually represent it by A as the distance from vertex to focus. Focus, we have here focus. And then, whatever the distance from focus to vertex, that is also equivalent to the distance from your directrix, which is A. So, this is our directrix. I will write here the equation, the line. Okay, this is our directrix. We call it the directrix. And then another equation of a parabola is, or another term that you must determine about parabola is the what we call as the Lattus Rectum. Okay, so I will change this one, parabola, our drawing of a parabola, like this one. Okay. So, one of the terms that we have to determine is the Lattus Rectum. We have this one as our Lattus. Okay, sorry for that. This is our Lattus Rectum. Oops. Sorry. I cannot do the line, perfect line. Okay, that is our Lattus Rectum. Now, the length of half of the length of a Lattus Rectum is equivalent to 2a. This one. On the other side, that is 2a. That means the total length of a Lattus Rectum is equivalent to 2a plus 2a, that is 4a. That is the total length of a Lattus Rectum. So take note, this is our Lattus Rectum. So I will write here our Lattus Rectum. So ito po yon. That line is what we call as the Lattus Rectum. Okay. So A to A. And then 4A, the length of a Lattus Rectum is equivalent to A for A. Now, we also have what we call as the axis of a parabola. We have this one as our axis of the parabola. Okay, that one is what we call as the axis of a parabola. So actually, from this parabola, it follows on the y-axis. Okay. Now, I will change this one, the color of our pen to, let's say, violet. Now, take note of the different terms in a parabola. Now, if a parabola is opening upward, if if a parabola is opening is at the vertex. I mean, if the vertex, sorry, if the vertex is at the origin, which means at 0, 0. So we have here, okay, sorry, when the vertex is at the origin and then opening upward, then we have our equation of a parabola, which is, take note, opening to positive y. So we have here x squared equals 4ay because it is opening to positive y. If we have the parabola is opening downward, sorry for this one, opening downward, this is opening to negative y, then our equation is x squared equals negative 4ay because it is opening to the negative y. Now, if the parabola is opening on the positive x, which means linear in x. So, our equation is y squared is equivalent to 4ax. And then, if the parabola is opening to negative x, this is positive x, this one is negative x. That means our equation is y squared equals negative 4ax. Okay, so if we say positive y, that is linear in y, linear. Okay? If the parabola is opening to the negative y, that means it is linear in y. If we say linear, the exponent is 1. Okay? Y, the exponent is 1. That is what we meant by linear. Okay? This one, if you have noticed, raised to positive 1, the exponent of x is raised to positive 1 because it is opening to positive x. So that is linear in x. Now, take note of the equation. If you have noticed in the equation, you have here 4a, you have here 4a, you have here 4a, and then you have here 4a. That 4a represents the length of Lattus Rectum, which is equivalent to this one, 4a. Therefore, when we solve a parabola, we need to find first the value of a by simply equating 4a equals. Okay? Now, we will have, what if, okay, we will have our example. Find the equation of the parabola whose latus rectum is 12 and the vertex is located at the origin. So, opening, we will say it is opening let's say opening upward. Okay, opening upward. So our solution now, if that is opening upward, then the solution is this one. Uh, Opening upward, that is linear in y. If you have noticed, opening upward, linear in y. That means we have here x squared equals 4ay. So find the equation of the parabola whose latus rectum is 12. So the vertex is located at 0, 0, and then the latus rectum equals 12. Therefore, 12 is equivalent to, x squared is equivalent to 12y, because this 4a is the length of a latus rectum, which is 12. So simply, we have this answer as our equation of the parabola. Now, if the center, if vertex is at HK, okay, if vertex is at HK, that means our parabola is located at HK. The vertex of the parabola is at HK. Then we have, okay, so we have, if it is opening upward again, and then the vertex is located at HK. This is HK. So remember, in our equation, x squared supposed to be, if the vertex is at the origin, x squared equals 4ay. Since they are open, the opening is at HK, so instead of writing x squared, that is x minus h squared, and then y minus k. That is now our formula. If the opening is downward, okay, and then the vertex is at HK, then we simply write here x minus h squared, and then negative 4ay minus k. Okay? If the opening is going downward, opening is downward, so we simply have here negative. If the opening is on the positive x, okay, is our parabola, then we have here y minus k squared is equivalent to 4ax minus h, because the opening is on the positive x. And then if the opening is on the negative x, we have here, take note, the center is at HK, then we have our equation y minus k square is equivalent to negative 4ax minus h. So the difference here is the negative sign, because it is opening to the negative x. If you have noticed this formula, it is opening to, the graph, it is opening to the negative x. So take note of that equation. If the vertex is at HK, so we will be using that equation. If the vertex is at the origin, so we will be using this equation. Okay, so we will have our example. Find the coordinate. Example, find the coordinates of the focus. Find the coordinates of the focus. Okay, find the coordinates of the focus and an equation of the directrix of, let's say, x squared equals negative 7y. Okay, so find the coordinates of the focus uh, and an equation of the directrix. Find also the vertex. The vertex, wherein for this case, we will find the coordinates of the vertex and length of latus rectum. Length of latus rectum, axis, equation of the axis of parabola, as okay, axis of the parabola. Okay, that's okay. So first, our equation is x squared equals negative 7y. Solution. Equation of directrix of x squared. So we need to find the directrix equation. So our parabola is, so I will change my color of a pen, my pen. So first we have our equation, x squared is equivalent to negative 7y. So if that is our equation, negative 7y, okay, so take note, this one is related to our equation x squared is equivalent to 4ay. So that when we equate this 7 and 4y, if we equate that one, we have here negative 7 equals 4a. So that a equals negative 7 over 4. Okay? So, that a is the length of our vertex to focus. Now, take note, from this equation alone, that is x squared equals negative 7y, the length of latus rectum, we already identified the length of latus rectum, which is equivalent to negative 7. For this case, our length of latus rectum is equivalent to negative 7, which is equivalent to 4y. So, take note of the length of the latus rectum. So, we go back to this one. Our A is negative 7. Now, if you have noticed, for this equation, we simply follow, this equation follows the format negative 4ay. So, if this is the case, we know that for this equation, this equation is the general equation of a parabola facing or opening to negative y. Okay? Opening to negative y. So, when we draw our parabola, we need to draw the parabola so that we can visualize our parabola. So, negative, let's say negative, okay? So, we have, take note, this is our vertex at the origin, and the distance from the origin to vertex, the distance from the origin, the vertex to focus, this one, is negative 7 over 4. So that's negative 7 over 4. When we use our calculator, we have here negative 7 over 4. Let me use my calculator. 7 divided by 4 equals 1.75. So, I will write here, if this is 1, okay, I will write it here, 1.75, 1, and then 2. So, most probably, andito po yung, this is our focus. 1.75. So, this is 1, this is 2. Negative 1, negative 2. Okay, negative 1, negative 2. So this is our focus. Length is, this is A. Okay, take note, this is A. And then on the upper part, you have here 1 and then 2. So this will be our, this is 1 and 2, so it is located here, 1.75. So this line is our directrix. Okay, this line is our focus. I mean latus rectum. Sorry for my line. Okay, so we have here. Okay, this is our vertex. So our focus, I mean 7. So if this is 7, 4A, 7, 4A. So 2A, which means if we have here 2 times A, so equals 2 times 7 over 4. So 1.75, we will multiply, calculator, 1.75 times 2 equals 3.5. So 3.5. So 3.5 on the other side and then 3.5 on the other side. So we will count here 1, 2, 3, 4. 1, 2, 3, 4. So 3.5 is located here. Okay, the other side is 3.5 located here. Okay, so that our graph now, okay, that is now our parabola. The length of this one is 3.5. And then on the other side, we have here 3.5. All in all, 3.5 plus 3.5, that is 7, which is equivalent to this one. Okay, so we have now the length of our parabola, I mean latus rectum, which is equivalent to 7. Now, focus, again, our focus is this one. The vertex is this one at the origin. And then our focus is this one, which is equivalent to, the value of x is negative, x is, I mean 0. Our focus f equals 0, the value of x, because it passed through x equals 0, and then y equals negative, negative 7 over 4. This one, negative 7 over 4. Okay, negative 7 over 4. So the focus. And then, coordinates of the focus. So we already find the coordinates of the focus, which is 0, negative 7 over 4. And then we also find the vertex, which is at 0, 0. And then length of the lattice, which is equivalent to 7. Now this time, the directrix. This is our directrix. Okay? Wherein, this pass through y equals, this is 1, 2. This is 1, and then this is 2, so 1.75. That is 7 over 4. So, it passes to y equals 7 over 4. Okay? 7 over 4. That is the equation of the directrix. And then the axis of parabola, of course, it passed through this axis. So, that is x equals 0. So, the axis of parabola, you have here x is equal to 0 because it passed through the y-axis. Okay, so that is how we find or how we solve the parabola. Okay. Now, another example is to write the equation of the parabola. This time we will write the equation of the parabola. Example, write the equation of the parabola with focus at negative 3, 2. Okay, so we have our focus and directrix y is equal to 6. So we have the focus negative 3 and 2, and then directrix equals y over 6. So write the equation of a parabola. Okay, so uh, let me check for this one solution. I'm not sure if okay, sige. We will solve this one. Okay, solution. Of course, we have to draw the parabola. First, we have the focus is at negative 3 and then 2. So, negative 3 our x and y is positive 2. So, that is located on the second quadrant. So, I'm not sure with this parabola. So, let's say, let me check this one. And then we have here x equals negative 3, 1, 2, 3, and y equals 2, 1, 2. So this is now the vertex of a parabola. I mean focus, not a vertex but focus. And then y equals 6, that is the directrix 1, 2, 3, 4, 5, 6. So we have the equation of our directrix. We have here red. So directrix is y equals 6. So we have this one. So this is our directrix. Which is y equals 6. And then the focus is this one. So if that is the directrix and then the focus, then our vertex is between the vertex and the focus. So to locate the vertex, of course, it is between the focus and directrix. So probably this one is our vertex. And then if this is our focus, then probably our parabola is facing downward. Okay? So that's how we draw our parabola. Now, that means the vertex of a parabola, because this one is our axis. Okay? This one is our axis. Take note, the vertex, the distance from the vertex to focus is A, and then vertex to directrix is A. They are equal. That is why we divide this one into 2, so we find the vertex of our parabola. Okay. Now, once we find the vertex, this one is facing downward, or the opening is downward. Opening is on negative y. The opening is at negative y. So if the opening is at negative y, then you have here x minus h squared equals negative 4ay minus k. We will be using this equation. Okay, so x minus h squared plus minus equals negative 4a y minus k. Now, if you have noticed, our a for this case is 2, 1, 2. So we will substitute the value of x minus h here is, what is the value of our h? X minus h. So we have here 1, 2, 3, negative 3. And then k equals 1, 2, 3, 4. Okay? So x, excuse me, x minus negative 3. X minus h, okay, x minus negative 3 square equals negative 4 times a. Our a is 2. If you have noticed here, a is equal to 2 from this case. A equals 2 based from the figure. 4 times 2. And then y minus k, our k is equal to 4. So that when we solve this one, that is x plus 3 square is equivalent to negative 8y minus 4. So when we expand this one, that is x squared plus 6x plus 9. That is equivalent to negative 8y plus 8 times 4, that is 32. So we will combine this equation, x squared plus 6x, and then negative 8y to the other side, that becomes positive 8y. And then 32 on the other side, so we have here 9 minus 32 is equivalent to 0. So you have here x squared plus 6x plus 8y, 9 minus 32, that is plus 23. I mean minus 23, which is equivalent to 0. So this will be the equation of the parabola. So again, take note, our equation of a parabola, we have the general form, take note of this one, the equation of a parabola. We have where if the vertex is at the origin, so we will follow all this format. And when the the vertex is at hk, that means it's not at the origin, so we will follow all these formula.